Welcome to the deep dive. Today we're pulling from a really fascinating case study by the MindStone-Agent team, and our mission is basically to answer this massive question in the AI world right now. Like, do you really need to pay top dollar for the newest, most expensive model?
Right. Yeah, it's the classic luxury sports car dilemma.
Exactly.
Yeah.
You know, when you buy a luxury sports car, you expect it to just, do everything better. Faster off the line, tighter turns, perfect handling.
Yeah, it's the premium experience. You're paying for peak performance right out of the box. But if you can't afford to drive it every day, you start looking at your reliable daily driver,
Right?
that trusty sedan, and you're wondering, well, can I soup this thing up to match the sports car?
And our sports car today is Claude Fable 5.
Yeah.
The drama around this model has been totally wild.
Oh, completely.
It drops, people just absolutely freak out because it's incredibly capable, and then it gets banned, and now it's back with these scary-sounding restrictive guidelines.
Yeah, though honestly, I haven't noticed any actual degradation in its performance since it returned.
Right? Me neither. But here's the real kicker. After July 7th, running Fable 5 is going to require extra usage credits, so it's going to become prohibitively expensive for most of us to use on a daily basis.
Which forces a highly practical question. Fable 5 significantly outperforms older models, like Opus 4.8, especially in complex, long-horizon development.
Yeah, so if we can't afford the Fable 5 sports car, can we use a systematic structure to soup up our Opus 4.8 sedan?
That's exactly what the Mindstone team tested. They wanted to see if a layered continuity architecture, or, an LCA harness, could close that gap.
Looking at the case study, their testing environment is just really clever. They didn't just ask the AI to write code.
No, they set up an entire review loop.
Right, with a paired agent team communicating over a network called Synapse. So essentially, one AI agent acted as the developer writing the code, and another AI acted as the QA reviewer checking it.
They basically made the AI check its own homework on real software tickets.
And then all those outputs were blindly evaluated by a mixed panel of human judges, like Clint Bodungan, right alongside other Mindstone agents.
Exactly. It sets up a perfect blind test. But when you pit the Opus 4.8 sedan against the Fable 5 sports car on these real-world tickets, what do you expect to happen?
Well, I have to push back a little on the whole premise here. Wouldn't the vastly more powerful Fable 5 just, invent a fundamentally better system from scratch?
You would absolutely think so.
Right. If it's so much smarter, wouldn't it build a completely different, vastly superior engine?
That is the logical assumption. But what's fascinating is experiment F in their study. The architecture actually converged.
Wait, really? Both models built the same thing. Why?
Because of the environment. Think of it like renovating a house.
Okay.
It doesn't matter if you hire an average contractor or a world-class architect. If the load-bearing walls and the plumbing are already set, they both have to work within the same basic floor plan.
Oh, wow. So in software, the strict constraints of the existing code base dictated the big picture design.
Exactly, not the AI's intelligence tier. 4 independent agents all landed on the exact same underlying structure because the existing code just forced them down that path.
Okay, that makes total sense. The environment creates the boundaries. But if the blueprints end up being identical, where does Fable 5 actually pull ahead to justify that huge premium price tag?
Detail execution.
Table 5.
Scored much higher on the finishing touches, like nailing the edge cases and things like idempotence.
Which, for anyone unfamiliar, idempotence is basically a fancy way of saying the system makes sure that if you accidentally run a command twice, it won't break anything or create duplicate actions.
Spot on. Fable 5 naturally handles those tricky lifecycle limits and safety checks. It just has a sharper, more refined execution on the very first pass.
So Fable 5 naturally writes safer, more polished code on the first try. Now, I know we've talked about LCA in the past. You can always check out MindStone-Agent.ai for the deep technical background on that.
Definitely do that.
But I really want to understand the mechanism here. How does that LCA harness actually fix the detail gap for the older Opus model? What is that QA loop doing to make it perform like Fable 5?
Well, this brings us to experiment G. In this test, they asked the models to build a greenfield app called Loopsmith Studio.
And a greenfield app just means starting totally from scratch, right? No existing code base, no pre-built walls to constrain them.
Precisely. The ultimate blank canvas test. And here is where the QA loop really shines.
Okay.
The Opus dev agent writes the initial code, which we know might lack some of those Fable 5 finishing touches, but then it passes that code over Synapse to the Opus QA agent.
Ah, so the QA agent acts as an automated critic.
Right, catching bugs, checking dependencies, ensuring coding hygiene. and it hands targeted feedback back to the dev agent, explicitly naming its mistakes.
And then the dev agent does a repair pass. It just fixes its own code based on the critique.
Yes, and because of that shipping discipline forced by the LCA review loop, Opus repaired its code to a perfect 25 out of 25 parity score.
That's incredible.
The system's structure compensated for the model's baseline weaknesses. It allowed Opus 4.8 to land comfortably in the Fable 5 quality band.
So what does this all mean for you listening? It means you can save a ton of money by routing your work smartly.
Exactly.
You use your cheaper daily driver, Opus 4.8, for the architectural heavy lifting, because the code-based constraints are going to steer the design anyway, and then you reserve your expensive Fable 5 credits, or use a really rigorous LCA QA loop for those tricky finishing details.
Right. If we connect this to the bigger picture, it proves that a smart workflow doesn't replace a model's capability, but it completely changes where you need to spend your premium compute power.
Which leaves us with a pretty provocative thought to chew on today. If a cheaper, older model can achieve state-of-the-art results just by having a QA counterpart name its mistakes, are we overvaluing raw generative AI power?
Oh, that's a really good question.
Right. And are we drastically undervaluing the power of automated critique?
Right.
It really makes you wonder if it's the luxury sports car you need or just a really good mechanic.